Hello, good day. In this virtual class, we'll be looking at how to derive complementary angles as regard to sine, cosine, and the tangent. Okay, from here we have a right angle triangle. That is the triangle A, B, and C. At C, we have the right angle. Okay, a triangle is said to be right angle triangle if one of the angles is has an angle of 90 degree. Okay, so here let's also look at what complementary angles are. If two angles sum up to give a 90 degree, it means that such angles are complementary in nature. Now let's look at this. We have at angle A here we have a theta, at angle B we have a alpha, and at angle C we have a 90 degree. It simply means that if we sum this angle, we have angle A plus angle B plus angle C. Here, this is angle A, B, and C. If we add them together, we sum them, eventually it definitely going to give us 180 degree. But angle A is represented with theta, while angle B is represented with alpha, and angle C is 90 degree as the numerical value is equals to 180. From here, angle theta plus alpha here. Here we have to move this way and become negative, and this is equals to 180 minus 90 degree. So here we could see that this angle theta plus angle alpha, they add up to give a 90 degree. So we could say that for instance, we could say that the angle alpha is equals to 90 minus theta. Okay, so let's take at it from that perspective. Now let's look at this how this works. Now imagine if we are looking at this angle from our Sokotoa. Okay, from Sokotoa. So here, let's look at angle theta. If we are looking at this angle theta here, the opposite is here. This is the opposite. That is side B, C. While the hypotenuse is usually the side facing this angle 90. And here, automatically, the adjacent to theta is the line AC. Okay, that is for this angle theta. Now let's derive simple trigonometric ratio for let's derive a simple trigonometry. So now let's look at sine. Sine theta, sine is opposite over hypotenuse. The opposite here is A, and the hypotenuse is the side C. Now let's look at cos theta. Looking at the angle theta, cos theta, which is K, is adjacent. Adjacent of this angle is the side AC, which is B, over the side of C. Let's look at tan theta, twa, opposite, which is the A, side A, which is the line BC, over the line AC, which is A over B. Now let's look at this angle alpha here. Let's look at angle alpha. we're looking at angle for alpha here, where if we're looking at alpha here, this become opposite. This opposite of that angle, and here become the adjacent. Meanwhile, the hypotenuse, usually it will remain the same. Okay, so let's look at that. We're looking at sine alpha, sine of the angle alpha, which is angle B. Sine here is opposite, which is B divided by C. Then let's look at cos. Cos alpha 2. K is adjacent over hypotenuse. Adjacent here is A over C, which is the line BC over the line AB. That's A over C. Now let's look at tan of the angle alpha. Tan alpha 2 is opposite over adjacent, which is the line B. That is the line AC, which is B, over the line BC, which is A. So now if we could see here that, let's compare. If we're looking at sine theta is A over C, so you will see that sine theta is has the same thing as what? Cos alpha. So here we could say here that cos alpha is the same thing as sine theta. So let's look at cos theta at the same value as sine alpha. So here we say sine alpha is the same thing as what? Cos theta. Then if you look at tan alpha, is the inverse of tan theta, or we could say that tan theta is the inverse of tan alpha. So but remember that so if we're looking for tan alpha is 1 is the inverse, which is the same thing as cot, okay, which is cot what? Cot theta, since cot is the inverse of tan. Okay, now these are just what we have here. Now if we replace alpha here, where we see alpha in any of these expression, okay, then the whole expression become here. The first one here we have a cos open bracket here 90 minus theta is equals to what? Is equals to sine theta. Okay, similarly we have here sine open bracket 90 minus theta is equals to cos theta. Then finally we have a tan open bracket 90 minus theta is the same thing as cot theta. So for instance, if let's assume that theta is 60 degree, so let's find the relationship between cos there. So here the first one we're going to have a cos, okay, open bracket 90 minus 60 is equals to what? Equal to sine 60. So here 90 minus 60, that gives us a cos 30 has the same value as what? As a sine 60. So similarly, if we put 60 here, you will see that since 30 degree at the same value as cos 60 degree. Similarly, tan 30 degree at the same value as cot what? Cot 60 degree. This is how to derive a complementary angle from simple trigonometry ratios. So please, if you find this video very useful, please subscribe and also share on your social media platform.